In this lesson, we're going to be looking at the triangle. We've looked at angles, and so if you look at the word triangle, you can see that in that word, we've got the prefix or the first part, tri, which means 3. Since tri means 3, we expect that a triangle is going to have 3 angles. Let's say we have a triangle ABC, which has angles that we'll label as 1, 2, and 3. Angle 1 is usually going to be referred to as angle BAC, or it can also be referred to as angle CAB. So any angle in a triangle has got 2 ways of referring to it. But what you need to always remember is that that symbol that we put on top is the one that showed us which is the common point. So from this name BAC, it means we have a line BA and a line AC, which are meeting at a common point A. This means that angle 2 can have the name ABC or CBA. Angle 3 can have the name ACB or BCA. That's how we name our angles in the triangle. Very simple, as you can see. These angles here can also be referred to by general names. For example, angle 1 and angle 2 are base angles. Angle 3, on the other hand, is a vertical angle. Soon you'll see that these names might be used. For example, some questions say that the base angles of a triangle are this and that, or the vertical angle is 30 degrees. The names that are going to be used are going to indicate particular angles. So now you know that base angles are angles like angle 1 and 2, and the vertical angle is an angle like 3. Basically, the vertical angle is that angle at the top of the triangle. The next thing we need to know about a triangle is the altitude. The altitude is also known as the height. If we have a triangle PQR, the altitude is the distance from side PQ to point R. To get that distance, usually what happens is we're going to draw a perpendicular line to the base, which is PQ, that is going to touch point R. To check your understanding of this concept, let's use some triangles. On screen you can see 2 triangles, XYZ and NAD. Which triangle has a bigger altitude? If you selected triangle NAD, then you know what altitude is. The triangle NAD has got a larger height. The next thing that we're going to look at is classification of triangles. With what we've covered so far, we can identify a lot of things about a triangle. It's very important that we're able to realize that triangles can be categorized into 2 types. The first is when we categorize them by sides, like was shown at the beginning of this video. We had 3 types of triangles. If you paid attention, we had an equilateral triangle, a scalene triangle, and an isosceles triangle. When we talk about an equilateral triangle, this is a triangle whose 3 sides have the same length. So if, for example, you measure a particular triangle, all of its sides are 30 millimeters long. That type of triangle that you have is an equilateral triangle. Whenever we have an equilateral triangle, all the internal angles of that triangle are going to be equal to 60 degrees. The next type of triangle is a triangle we call the Scalene Triangle. This is a very interesting triangle to construct. The main difference about this triangle is that none of its sides have the same length. Each of the 3 sides is going to have its own length. The next is an isosceles triangle, which is a triangle that has 2 of its sides that have the same length. In the diagram here, those 2 sides are this one and this other one. Whenever this happens, the type of triangle is called an isosceles triangle. Additionally to this classification of triangles by sides, they can also be classified using angles, particularly the internal angles. An internal angle is just an angle found inside a triangle. For example, here we've got an acute triangle. What makes it an acute triangle is that all of its internal angles, this angle here, the angle here, and the angle here, are all less than 90 degrees. So you might be thinking, well, can't we have an acute triangle that is an equilateral triangle? Yes, that is very possible. Hence, what you notice about this classification of triangles is that it can somehow be interconnected. You can refer to one triangle using any of the two methods, and both of them are going to be correct. For example, here we can have a triangle that is known as a right-angled triangle, which someone might say arguably is a scalene triangle. That is not a problem. However, in some cases, it would be better to just call this triangle a right-angled triangle rather than a scalene triangle. What makes it right-angled, you may ask? The fact that this triangle has got a 90 degrees angle as one of its internal angles, this is why it's being referred to as right-angled. So the term right-angled simply means we have an internal angle that is equal to 90 degrees. And that angle is shown by this small square here. Apart from the acute and right-angled triangle, we have another triangle which is named as the obtuse triangle. It's obtuse because one of its internal angles is greater than 90 degrees but is less than 180 degrees. This angle here is the one that's making this triangle be called an obtuse triangle. In some cases, an obtuse triangle can actually be an isosceles triangle if two of the sides have the same length. The first type of triangle we're going to draw is an equilateral triangle. An equilateral triangle is a triangle that has got three sides that have the same length. We're going to construct an equilateral triangle with the side length of 70 millimeters. Mark a construction line that is going to help us make our base. This is triangle ABC. It's a good thing we label. That is AB. And now we're going to draw our triangle. Now, notice something. The easiest way to draw our equilateral triangle, since we know that it's got sides of the same length, is just standing at B, then striking an arc, standing at A, and striking an arc also. The point where these arcs meet is C. And now when we join the points ABC, we have our equilateral triangle.